So, yep, yep, it's that time. Benchmark me. I'm having flashbacks. Ugh. Benchmark me. Well, I can't benchmark you because well, it's not time yet. Build? Yeah, we can do a build. There you go. Here's our build. I can't really show you anything else. If you're gone yet, buy me. Buy me. Buy me. Pre-orders are good. Buy me. This is obviously not retail packaging, just FYI. But it is exciting because this is the new 10th gen Core i9 and the new 10th gen Core i5. 6 cores and 10 cores, 20 threads, 12 threads. 5.3 gigahertz out of the box with a velocity boost, assuming that you can keep it cool. We're gonna do custom loop cooling on this, among other types of more exotic cooling. Let's take a look at the motherboards. This is the Aorus Z490 Master. So I know what you're thinking. Oh, it's a new socket. It's time for a new chipset upgrade. No, no. It's still DMI 3.0. There are improvements to the platform. The platform now includes optionally 2.5 gigabit Ethernet from Intel, which is nice. Yes, the CPU does drink the power. 325 watts from the wall for just the motherboard and CPU. Like, basically, like you do like the multi-core enhancement, and you're gonna run it at that 5 gigahertz plus mark on all cores, 325 watts and up. So the Z490 Aorus Master, talking about PCI Express layout, it has 3 physical by 16 slots that are full length, but these are implemented pretty much the same way as Z370 and Z390. 16 lanes to the CPU, and all the other lanes are through to the chipset. So you got 2 slots in a by 8 by 8 configuration to the CPU, or 1 slot at by 16. Your other slot is through the chipset. The chipset link to the CPU is still that DMI 3.0. It's a maximum 4 gigabytes per second. So a single really high performance NVMe is gonna saturate that DMI link. If you've never built your own computer, there's never been a better time to build your own computer. This is the scariest part. This is the part that is most likely to result in you murdering something that costs hundreds of dollars, and that is installing your CPU. So there's little notches on the side and a little triangle to help you orient the processor the correct way. So you want to look for the little notches before you set the CPU in there, and then you just set the CPU in there, and then you just, there's this little plastic thing on the clip, and you want to save that too. So you don't take it off, you just, when you put it on correctly, it comes off of its own accord. This is a protector, a socket protector. So if there's no CPU in there, this little piece of plastic will protect that socket. And you got to save this, because if you ever do have to return the motherboard for some other reason, it's got to go back to them with this little piece of plastic installed. So I'm putting that back in the box. I didn't intend for this CPU review, the CPU launch video review, to be how to build a computer. So let's build the computer. Let's put the rest of it together, which is pretty much paint by numbers, and see what kind of numbers we're looking at in terms of the benchmarks. Now, one of my favorite games in the world is Stellaris. Stellaris is multi-processor, like it's multi-thread. It's pretty well multi-threaded, but it still kind of depends on single thread. So like when you want to run as fast as you possibly can, toggling the fastest speed on, that still seems to be dominated by single thread speed. And at least that the 3950X that I'm usually running it on seems a hair faster than a 3970X Threadripper, which doesn't sound right until you realize the 3950X can boost up to about 4.7 gigahertz. So I thought, what better test than to test this on the 10th generation Intel Core i9. So this is not as scientific as a test as I would like, because the game does not have a built-in benchmark. What I did was create a save, and this is sort of late game, end game stage where the universe is really populated. The game tends to slow down because it's kind of complicated. There's a lot of empires here vying for resources, a lot of ships, a lot of movement. There's a lot of stuff that the game has to keep track of. I know from the documentation on the game that when you've set it to fastest, the game will play literally as fast as it possibly can, as fast as your machine can keep up with it. So I set it to the fastest speed in this late game, and I was fully expecting that 5.3 to 5.4 gigahertz Intel 10-core chip to take the lead, even though I'm rocking a more expensive 16-core machine for comparison. The 3950X, it's $250 more expensive as a processor. Well, it turns out that the 3950X actually edges it out by a measurable margin. So one of the things I'm doing in the game is building a Dyson sphere, and there's all the stuff going on in the background, but I loaded the same save on both machines to look at how long it's taking to build the Dyson sphere around a star. Dyson sphere is really cool because it's this theoretical, probably, device that you build literally around a star that harnesses all of the solar energy and emissions of the star and turns it into energy. Well, the United Nations of Earth is just about to get one such Dyson sphere. Now for the i5, I repeated the same test. The Ryzen 5 3600 versus the i5, at least just using Stellaris. And the speed was very, very close. It was much closer than on the other higher end systems, much closer than I expected. If anything, the Intel system is slightly faster than the Ryzen 5 3600, but subjectively, playing it in the game, there's random events after I load the save game. It was within 3 days, running over a 1 minute period. The amount of progress that I had on my Dyson sphere was basically identical between each system, with a slight edge to the Intel processor. 5.2 gigahertz all-core Shadow of the Tomb Raider. I feel like most people should be able to achieve 5.2 gigahertz, even though we were able to push a little bit further than that even. 170 FPS at 1080p with our super crazy overclocked Gigabyte 2080 Ti. Yeah, that's a new record. That's the fastest that, it's in the range of the fastest that we've ever seen Shadow of the Tomb Raider. Now, it's fastest by 3 to 5 FPS, the 9900KS with its, 5 gigahertz, 5.1 gigahertz, all-core overclock. But yeah, 167 FPS versus 170, that's pretty nuts. It was slightly faster. It's close to margin of error, but on repeated runs, slightly faster in terms of the minimums as well. So, not too bad. And of course, 87 FPS, a little bit faster even at 2160p, and 2160p is definitely a GPU limited scenario. We've also got comparison with the 3900X and the 3950X, but I think the real comparison CPUs from AMD would be the 3900X, which is, MSRP is $499, but I can't help but notice that it's also been on sale lately for about $400 US, so this is going to come down to price a little bit depending on where you are. Of course, the 9900KS debut price was $513, although in retail circles it was a little bit more expensive than that. So the price point for the 10900K at about $488 US. That's come down a little bit. You get 2 more cores for a little bit less money. That's what I like to see in the market. Tom Clancy's Wildlands is another one. With 1080p on that super fast 2080 Ti graphics card, 142 FPS versus about 120 FPS on the competing 3900X. I mean, this is clearly a win for gaming scenarios. 69 FPS even at 2160p versus 61 FPS. That is a pretty big difference even at 2160. I mean, the difference between 61 and 69, but the difference between 120 and 142, that's a pretty big difference. Tom Clancy's Wildlands, when we look at maximum and average CPU utilization, it tracks about like you'd expect. We're looking at about 23% CPU utilization on the 9900KS and 19.4 CPU utilization on the 10900K. Far Cry 5 overall, 148 to 150 FPS on the 10900K versus 112 to 127 FPS on Team Red. That is a decisive win for Intel when we're talking about Far Cry 5 with the highest end GPU that you can get at this point. Of course, if you don't have a 2080 Ti, the differences here between the platforms are going to be much more minuscule across most of our gaming workloads when you look at the graphs. Now, what about multi-core? Multi-core is something that AMD has really just been incredible. We moved from 8 cores to 10 cores. We've got 2 more cores, but we also have a little bit better clock speed. Well, Indigo is basically neck and neck, but if you get the overclock with the 10900K, you can actually surpass the 12-core 3900X. Out of the box, the performance between the 10900K and the 3900X from AMD is pretty close.
it slightly favors the 3900X in some scenarios, especially scenarios that scale really well with a lot of cores, things like Cinebench. I was surprised that Indigo Bench was as close as it was, but it's basically a wash with Indigo, depending on what scene that you run. Slightly favoring the 3900X perhaps, but this is still a really good result for the 10900K. Cinebench is another one. It's about 529 to 540, depending on if we're talking about a 5.2 to a 5.4 gigahertz overclock. Our overall score is 6998 in a 5.2 gigahertz scenario, which is a little less than 7125 of the 3900X, but again, that's pretty close. Sometimes with CPU architecture, you worry about just tacking on 2 more cores. We go from 8 cores to 10 cores. This is a ring topology. The topology of the processors on the 10900K is completely different than the 10900X. The 10900X, single thread, just cannot touch the desktop processors. And so the naming scheme is a little unfortunate perhaps, 10900K versus 10900X, because, oh, it's just 1 letter difference. No, there's a huge difference between those processors. The 10900K, being a ring bus, you start to worry about so many cores on the ring bus and how that's going to be affected by different workloads running at the same time. One of the big advantages that Intel's competitor enjoys is that if your computer's doing a lot of different random stuff in the background, the physical chip architecture from AMD is pretty well suited to that. There's not really like a noisy, application running in the background is not going to adversely affect a program in the foreground because they're able to run on physically separated resources on the chip. Everything is a lot more tightly integrated on Intel chips. That's why the latency is so much lower among other features. And it makes for a nice, snappy, responsive system. The problem is that it's diminishing returns the more cores that you add. Adding 2 more cores doesn't proportionally increase the computational horsepower necessarily. So you run certain benchmarks like Cinebench and V-Ray, you sort of expect that maybe the performance will kind of trail off a little bit. But actually we see the 10900K in these scenarios really holding its own. I mean, it's a 10-core processor that is competing with a 12-core processor in a lot of cases. I also ran some testing with SpecViewPerf. Now the thing to note here with the SpecViewPerf testing is I tested it against the 3950X. I really gave AMD as much of a wide berth as I possibly could here, and I also threw in the 9900KS, the last gen CPU that was at a little higher price point, and the performance of all of these CPUs was really good. It was pretty similar across the board. Maybe the one notable exception is Maya, and that goes back to the optimizations that I was talking about. Intel sort of wins by default because there are optimizations for Maya. I am sure that when we're talking about 16 cores for the type of testing that SpecViewPerf 13 is doing, 16 cores versus 10 cores, that's going to be a big win for AMD if the optimizations are in place. But for SpecViewPerf 13, no, the 10900K takes the crown. And the performance here really is, the difference is pretty significant, and the difference is even higher than the 9900KS, and this is at a 5.2 gigahertz, a relatively pedestrian 5.2 gigahertz clock. Geekbench, of course, tracks about like you would expect. This is completely stock settings except for XMP, so 1453, that may have been thermal velocity boosting to 5.3 gigahertz. I'm not 100% sure about that because the tools that I have to use for reporting that, I'm not really sure we're displaying that correctly, but yeah, 11,686 overall score and 1,453 single thread. Compare that to the 3900X at a similar price point, and it's about 1298. The single thread scores fair bit worse. 12,864. Multi-core is of course better because you got 2 more cores. Now again, this testing is with the 2080 Ti, which really amplifies the difference between Team Red and Team Blue, and especially at 1080p, because it's that sort of round trip time, like how fast can a processor access memory, dump stuff on the PCIe bus, and that total round trip time, especially when we're talking about relatively small amounts of information. I mean, 140 FPS at 1080p, that's not a small amount of information, but the faster you can get everything from memory to CPU and back out to the PCIe bus, that's going to give you a performance advantage, and clearly we see that here with the 10 core.
Now you might be wondering about 10th gen and Linux. Well, I'm happy to report, at least with Fedora and the relatively recent kernel, everything is working great.
boosts up to 5.2 gigahertz. Now that extra thermal velocity, 5.3 gigahertz, I'm not sure that that's working exactly as intended. Fortunately, the BIOS on the Aorus motherboard, you can set 5.3 gigahertz and it seems to do some magical overriding. And so I was seeing 5.3 gigahertz, even a little bit of fleeting 5.4 gigahertz on the BIOS. So things like turbo, power management, thermal throttling, all of that is working correctly on the relatively recent version of the Linux kernel. And 10 cores, 20 threads at over 5 gigahertz for pretty much everything that you would be doing is a really snappy and pretty glorious Linux experience. The one place where it falls a little short is with IOMMU and virtualization. So you got 10 cores, it'd be great to be able to run a virtual machine with hardware pass-through. Well, there's 16 PCI Express lanes directly into the CPU. If you run 2 GPUs in an x86 configuration, bad news, both of those GPUs are in the same IOMMU group. So you can use the ACS patch and split it out, but it can be a little flaky and there's not true separation of your PCI Express devices. I fiddled with the UEFI settings, but that's pretty much been par for the course since I think Z270. I tried breaking out the X8 slot into 4x4 slots through a PLX bridge even, and everything was all still grouped together in group 1. So not an ideal situation as far as virtualization goes. That said, the Linux experience with 10 cores that are this fast, it's a dream. The machine is insanely snappy. I mean, you can bog it down with like tons and tons and tons of background tasks, but 10 cores, 20 threads is a beast of a Linux machine with the i9. The i5 was a similar experience. 6 cores, 12 threads. That's also a pretty beastly Linux machine. The IOMMU, everything else sort of follows suit. You don't really get the thermal velocity boost features. You shouldn't expect those to work because those are really reserved for the higher end. But you can do a manual overclock, and 5.1 gigahertz on the i5 was no problem, and it was pretty stable in Linux. Overall, Linux support, motherboard features, sensors, everything else, A-. For virtualization, I think you'll have to move up to a more expensive platform if you want to do the hardware pass-through for virtualization. You can try the ACS patch, but you're rolling the dice. So for the i9 overall, what you can take away from this is that Intel is doing pretty well, but there's something better on the horizon from Team Blue. These are perfectly reasonable CPUs. I mean, at $488, it's not a terrible deal. The single thread performance is unmatched, but 10 cores versus 12 cores on the competing platform, depending on what you're doing, you will have a marginally better experience, you know, for another processor. The other thing that will drive up the cost of your machine is cooling. So with the 10900K, it was not unusual for me to see the system, you know, pulling 375 watts, especially with that overclock. And so you need really good cooling. We use the Fractal Celsius S28 Plus for most of our testing, and this cooler has trouble keeping up. I mean, it's a good 280 millimeter cooler. It's got great cooling capability. It really had trouble keeping up with the 10900K, especially when we were pushing past that 5.2 gigahertz clock speed. 14 nanometers is just, it's incredible that Intel's been able to get over 5 gigahertz sustained and stable. Like, I tried to abuse the system. I've really tried to make it unstable. I pushed it to 5.4 gigahertz, and I was getting thermal throttling all over the place with the Celsius S28 Plus. Taking the Celsius S28 Plus out of the equation and upgrading to an EK custom loop, custom loop with the Performance 360 kit, that's what it takes to tame this thing when you're pushing past 5.2 gigahertz, 5.3 gigahertz, all core, 5.4 gigahertz, on like 8 cores-ish at some still pretty scary temperatures. You can do it, but it's not a lot of fun, and it's going to be really expensive. You're spending almost as much on your cooling solution with the EK kit as you did on your processor. That's not really a good place to be in. Whereas on the competing platform, it comes with a box cooler that is perfectly reasonable to achieve the advertised speeds on the box. So it can drive up the cost of your machine, even if you're just looking at processor price comparison. It's really going to come down to value and what's available in your market, and whether you have to have the fastest possible frame rates at resolutions like 1080p and to a lesser extent 1440p. The other nice thing with this Intel sample CPU is that it was fairly well overclockable. The i5 speeds are pretty conservative, but overclocking it to 5 gigahertz on all 6 cores, 12 threads, it was easy. And you're going to have a little better performance than an 8700K for just shy of $200 US. That's really good. You can pair that with a reasonable cooler. You don't have to go crazy like the Celsius S28 Plus from Fractal. You can also do one of the Be Quiet tower coolers that are on the order of about $50 US, and that will give you a reasonable experience with this i5. Depending on what you're doing, depending on, because the amount of load that a particular game has from time to time, you might be able to get by with $100 cooling and 5 gigahertz to 5.1 gigahertz and rely on that thermal velocity boost. It's not a bad experience, it's a really neat feature. But if you've got a processor like the i5, a little bit more pedestrian, then you're not going to have thermal velocity boost, but you can do the overclocking because it's an unlocked chip. You just have to sort of dial it in yourself. And if you're buying the i5, you probably don't want to buy a CPU cooler that's north of $100 because then the value proposition is kind of out the window. So it's a really interesting situation for Intel. Plus, these motherboards really give away the fact that there's something else on the horizon. And so I think that puts shoppers in kind of a precarious situation because it's like, well, do I want to buy the 10900K and then in fairly short order upgrade to something else? Or how far away is the next thing? Is it 3 months? Is it 6 months? Is it a year? I mean, I don't know. If I were buying or building a system right now, I would be super excited because we've got all these wonderful parts at all these relatively wonderful price points, at least compared with, a year ago, 2 years ago, 3 years ago. And the thing that we have to thank for that is fierce competition. It's really an amazing time to be buying or building a machine with parts like these available. So again, thanks to Intel for supplying these CPUs. This is not the last that we're going to see of these CPUs, but it was really interesting to see the performance. Oh, and there are some performance anomalies with having 10 cores on a ring bus type CPU, but we're going to come back to that in another video. Mostly everything's fine, at least for like the gaming scenarios and things ordinary people would be doing, but there you are. I'm Wendell, this is Level 1, I'm signing out, and I'll see you later.
It smells like the Corona.
I'll take this second to remind you of this camera.
Oh yeah, I forgot about that one.